Alrighty. Here we are. All right, so welcome everyone. How was lunch? Good? All right, good. Aloha everyone. I am in my Hawaiian aloha shirt. I just came off and got, microphone, thank you. I just got married and so I was just on my honeymoon. So welcome everyone to my, thank you, to my post-honeymoon slideshow. I'm kidding. We're going to talk today about securing Helm 3 and what that means. So a little bit about myself here. I'm Matt Fisher. I'm a Helm core maintainer. I'm a software engineer at Microsoft. I've been working on Helm now, I think, 3 years. Don't quote me on that. I think it's more like 2, actually, is officially. But I'm Bacon Gobbler on Twitter, GitHub, Slack, anywhere you can really find me on social media. So the agenda for this talk, I'm going to talk about a very, very quick, brief overview of Helm 2 security and how it relates to this talk. Then I'm going to talk and how it relates to Helm 3. We're going to talk about user management in Kubernetes, just a very basic how that works, and then role-based access control and a little bit of a demo. So the format for this is that I'm just going to fly through the slides as quickly as possible to get through the demo, because that's really going to be the good meat of the content, I think, here. So how many people think they're a little bit of a Kubernetes security expert and they've played with like open policy agent, they've worked with network policies, pod security policies, auditing, all these things that are up on here. This is basically when you're talking about securing Helm, this is a lot of the things that you're trying to talk about. And I wish I was there for Paul's talk actually on hacking Helm. But these are a lot of those concepts that you can talk about. So tiller, chart provenance, user management, cert management, role-based access control. So Lockie gave a talk at last Helm Summit, and I absolutely love this quote, so I had to bring it up again. The only truly secure system is one that is powered off, cast in a block of concrete, and secured in a lead-lined room with armed guards. This is a quote by Gene Spafford, and it's personally my favorite quote, so I just had to add that on there. So I'm not going to go into too much overview or any overview of like Helm 2 security with Tiller and everything else. Lockie did a fantastic talk and overview of that at Helm Summit North America. So if you want to, that QA code or QR code over there, you can take a picture of it. And that will take you right to the YouTube talk. What we're going to talk about today is Helm 3 security. So this is the exact same slide that we were talking about before. Notice that only 2 things have been crossed off the list when we're talking about Helm 3. Tiller, the certification management, and role-based access control management in terms of Tiller's role-based access control. However, we still have a lot to cover. We're only going to cover 3 today because there is so much to cover on everything else, but we'll get there, and then hopefully we can give an in-depth guide of those things. So, in a nutshell, when we're talking about Helm 3, we're talking about the CLI tool. So in Helm 3, it is just a CLI tool that interacts with the Kubernetes cluster. With Helm 2, it was Helm 3 talking over gRPC to talk to Tiller. 3.00 beta 3 is what we're using in this demo. That's the current preview release that was released last week. So that's what we're going to be showing off. And then again, yeah, Tiller was removed as a component. The business logic, however, is now all part of the Helm CLI. The only thing is that we're just removing the gRPC protocode and all that kind of fun stuff from Helm 2. The thing that is very parallel to this demonstration is actually kubectl. They share the exact same security models in terms of how you access a resource, how you deploy a resource. If your user account that you set up for your Kubernetes context does not have the correct permissions, it won't be able to deploy in certain namespaces. So we'll show that in a bit. And this is a community effort. This is just one part of the security story. There's also, like I said, the network policies. There's the pod security policies that a lot of people have been talking about, doing linting and chart testing and all that kind of fun stuff. So this is a community effort. There's so many facets of this. So we're only going to leave a few basic scenarios, and we're going to leave the rest as homework for the reader. So user management. How many people have played with Kubernetes management more so than just the first default user that's created in Kubernetes? Actually, that's nice. There's a fair few of you. So there's a concept in Kubernetes. It's called service accounts and user accounts. For those that don't know, service accounts are the things that are managed through the API. That's basically like a client API. You use that when you're interacting with the Kubernetes API, and that's kind of like a machine. It's used to represent applications communicating with the API, either internally or externally. User accounts, however, which is the part that you're using to represent a human interacting with a Kubernetes API, is not a cluster resource. It's not something you do a kubectl create user. That's something that I have to do at the controller side. User accounts can be configured through the API server, and they're managed externally depending on whatever way you've set it up with TLS certificates, bearer tokens, username or basic username and passwords, and OpenID Connect tokens. In this demonstration, we're only going to show one scenario, which is just using TLS certificates. So how that process works when you're creating a brand new user into Kubernetes is you first generate a private key to identify that as the user. You generate then a certificate sign request to say that I want to sign as, or I want to authenticate myself as this user against this cluster. Then using the Kubernetes cluster's certificate authority, you sign that certificate sign request, and that gives you a public key. That's what you use with the Kubernetes cluster to say, I am acting as behalf of him or her. Then you create, now you're actually getting into the role-based access control stuff, so you create role bindings for the new user. When you're the first user created on Kubernetes, you are given cluster admin access, so you can create these role bindings and whatnot for the first user, so you have to be a cluster admin. And then you just add these public private keys to your Kubernetes config locally, and you create a new context for your account, so that's how you authenticate against the cluster. Now we're actually getting into the role-based access control part of it, which is, this is how you are given these or granted these roles to be able to deploy into a namespace, given read-only access to certain namespaces, or not. And by default, when you create a brand new user in Kubernetes, you are given no authentication whatsoever. Only the first user has cluster admin access, and then it's up to the cluster admin to make those roles. And then for Helm 3, how this relates to us is that when we're authenticating against the Kubernetes cluster, has anyone worked with the --kube context flag before? Okay, yeah, a few of you. So that's the flag that you can use to switch on the fly in your Kubernetes config to say that I want to authenticate as this user in my Kubernetes config. Or you could do a kubectl config set context, so then you can change your default user when you're authenticating, but that's how it works in there. So when first creating a new user, there are a lot of information out there on the internet about telling you to create the following cluster role binding, which is to give you cluster admin access and play around with that. This is basically equivalent of saying that all your base are belong to us from this point forward. This is not a good security policy going forward. So let's actually dive into what are some of the other ones that could be usable for whatever scenario you need. There's cluster admin, which I mentioned, that's the God mode. The first user created has this mode. There's, by default as well, there's an admin role base or binding. That gives you read-write access to most of the resources into a namespace, including roles and role bindings. But it does not allow you write access to the resource quotas in that namespace or to the namespace itself. So if you give someone admin access, they can't actually delete that namespace. If you grant them edit access, it's basic read-write access to most resources in a namespace. It's a little bit more restricted than admin, so you can't do other things. I think it's you can't see the roles and role bindings is the other part. So there's that. And then there's view access. And this one's a little bit tricky. We'll get into it in a second. But it gives you read-only access to most resources in a namespace. But it does not give you access to roles, role bindings, or secrets. So you'll notice that in something in Helm 3, we use storage or secrets as storage. So we'll have to work with that in a moment. But we'll cover two basic use cases in this demonstration. We'll give read-only access, which is Helm list, Helm status, and Helm history. So you can take a look at what the status of a deployment in another namespace is like. The other basic use case is read-write access. So if you want to give a user be able to do a Helm install, an upgrade, a rollback, a delete, or an uninstall. Quick side note about the view cluster role, as I mentioned before. It's a little tiny up there, but it says it allows read-only access to see most objects in a namespace. It does not allow viewing roles or role bindings, and it does not allow viewing secrets since those are escalating. Not actually quite sure what it means by it's escalating, but I'll figure that out sometime. That's homework left for the reader. Helm actually stores the release metadata as secrets. So in order for us to gain read-only access to, say, Helm list, we need to see that release metadata. So we'll need to create a special cluster role that's similar to the view-only role, but for secrets. So there's this one. It's actually in the Kubernetes documentation if you want to create a secret reader cluster role. And what this does is it gives you API groups, nothing there. It just gives you access to the resources of secrets. It lets you to get, watch, and list are the API endpoints for that. So if you do a kubectl create -f with that cluster role secret reader, you're all good to go. And then a last thing I also want to add on here about the edit cluster role. If your charts that you're depending on, they create roles or role bindings in the actual chart, the edit cluster role does not give you access to create those roles and role bindings. So you need actually the admin cluster role instead. Something quickly note. And if your charts manage cluster-wide resources, custom resource definitions, those are cluster resources, which means you will need cluster admin access. And again, refer back to the first image. So now let's actually look at some practical examples here before we go into the demo. So if you're giving a read-only access for a user against a particular namespace, you're going to need in Helm these two different roles. Which is a view cluster role and then a secret reader cluster role with that API that we created before. Read-only access for a user cluster-wide. I'll quickly go through these and then I'll show them in the actual demo. But we've got the read-only access for a user cluster-wide. This is important for when you want to do a cross-cluster, see all the namespaces or all the deployments that are available on every namespace. You need to have secret reader access and view so you can see those resources that are being deployed. And then for service accounts, same thing. You're just doing it with service accounts cluster-wide, which is kind of highly discouraged because what that means is essentially you are giving any single service account that is created in the Kubernetes cluster complete view access to absolutely everything else. Generally, you can give a little bit more of a secure view. You can do it if you want to, but it depends on your attack scenarios and everything else there. So that's read-only access. Now we're going to talk about read-write access. So that's, again, the edit. So you'll notice here we don't have a secret reader because the edit gives us secret access, so we can write those resources. So in this example, we're just going to, inside a particular namespace with one user, we'll just create that role. Service account in a particular namespace, same thing, except we're just changing it to a --user to a -- service account. Read-write access for all service accounts in a namespace. So we're just giving all service accounts that. And then this is like the cluster admin access again, which is creating a cluster role binding for all service accounts in your cluster. You're able to edit anything in there except for namespaces and the quotas again. Super highly discouraged because you can delete any of the resource. One more time, all your base file belong to us. So let's go to the demo. All right. So can everyone in the back see the screen? Is that big enough, or do I need to make it a little bit bigger? A little bit bigger? Oh, you're saying it's okay. Okay. So for this demo, I'm just going to show a Minikube status. I'm just running with Minikube here because it's just really easy to get access to the certificate authority, so then I can actually create new users rather than having to go through the cluster admin, SSH into the cluster, figure out what the certificate authority is. So just for demonstration purposes, it's going to be super simple. But let me show you what we're going to do here. So we got a couple of scripts here. First one, we're going to create a user called Sam. Sam is just going to be giving their own namespace. kubectl create namespace Sam. And then as per the Kubernetes documentation for creating a new user with TLS certificates, we're going to generate a new private key for Sam. Then we're going to generate a certificate signed request. We're going to give them the username Sam and the organization is Helm Summit. And then using the CA certificate or this certificate authority that is created with the Minikube cluster, we're going to sign that certificate sign request and say, yes, it's okay to use you. I authorize you as a user to go and authenticate against this Kubernetes cluster. And then we're going to give them 500 days to work with it. And then at the end of the script, we're just setting our Kubernetes or kubectl configuration. We're going to set a new context and the credentials for that user for the Kubernetes or Minikube cluster. And then we're going to give them the namespace. Actually, that's a typo. We're going to do it not in the shared namespace, but in the SAM namespace. There we go. Earlier demo problems. So we're just going to run that script. And that's going to do absolutely everything that we mentioned here. So we created a new SAM certificate, the private key, the certificate sign request, and the public key here. We added it to our Kubernetes config, so everything's there. Now we're going to do the exact same thing. We're going to create a user for me called create bacon gobbler. So let's go into the actual cluster, and what does that mean? So if you go namespaces now, we have a bacon gobbler namespace and we have a SAM namespace. We're going to show this off as where the bacon gobbler namespace is what I'm going to be giving myself read-write access, and then SAM is going to have read-write access to the SAM namespace. And what I'm going to demonstrate is myself, bacon gobbler, is going to be able to also have view access into SAM's namespace. Now, when we first created those users, we did not get any roles assigned to all of us. So we can actually show that, because if we do a Kubernetes -- context, bacon gobbler, if we do, I think it's just get pods, we will not be able to see absolutely anything in the namespace bacon gobbler because we don't have any roles assigned to us. So, and if we do a Helm list with that same thing, Helm -- kube context, bacon gobbler, list, we don't see anything at this current time. If we installed something, we would not be able to install anything. So we try install, let's do WordPress, stable WordPress, and then we'll give it a fancy name. This will not work because we don't have read-write access into that namespace. So we need to actually go and create those roles for that user. So we're going to use another script to actually go and do that here. So the edit4.sh script here, just as we showed before, it just creates a role binding in that namespace for a particular user, and then in a particular namespace. So we're going to give that, it was edit4 bacon gobbler, and we're going to give bacon gobbler edit access into the bacon gobbler namespace. So now that role base, or that role has been created, or that role binding has been created for us, and now we can install charts into that namespace. And there we go. We got namespace in there. If we do a Helm list in there, list, we can now see that. So we've got the WordPress generated name in the namespace bacon gobbler. It's all been deployed. Everything else is all fine and dandy. Now, what if we're user SAM and we're trying to see what bacon gobbler has deployed? So if we do a Helm kube context, SAM list, let's try and do the namespace bacon gobbler. We can't see anything because we don't have view access over to him or her. So we're going to do a view for them. We're going to do a view for that script is just a role binding. And again, notice that this has the secret reader cluster role binding, or the cluster role that we created before. I didn't show it in the first script. It uses the cluster role secret reader and it creates that instance, and that is in the cluster role secret reader.yaml. So that's creating that cluster role secret reader, API groups, resources, secrets, get, watch, and list. So we can actually just view the secrets. We can't edit them. So now we'll do view for SAM, and we'll give SAM view access into the bacon gobbler namespace. So that's been created. So now what we can do in Helm is kube context. What time are we at? We're good. SAM. And then we can do a list. We'll see there's nothing because we're not looking in we're looking in our own namespace. There's nothing there. But if we look in namespace bacon gobbler, we start seeing other things. Now, what if we want to actually see everything from a holistic point of view? So we want to see absolutely everything in the cluster at any point. That is a completely different role. than what was shown here. So if I try and do that right now, all namespaces. So SAM does have access. A role has been created inside of namespace Bacon Gobbler that SAM can see all those resources in there, but can't. But now when we press this, we're trying to see everything at a holistic point of view. We can't see anything. This is a separate Kubernetes endpoint in terms of how the API works. When you use the all namespaces endpoint, you are seeing things from the cluster point of view, from a holistic point of view. So it's not a fine-grained role. You have to create a cluster role to be able to view those resources. So we have another helper script here. It's called cluster role view 4. And that script is a cluster role binding for viewing resources in any namespaces as a particular user. And the secret reader, again, because of secrets not being viewable, but with the view cluster role. So we will do that, and we will give SAM access. So now those two role bindings have been created for SAM. And if we do a Helm kube context, SAM list all namespaces. And now we're able to see inside of every single namespace anything that's been deployed inside of there. So that is the majority of what I got here. And then again, if I just want to be able to do one last thing, which is give Bacon Gobbler edit access inside the SAM namespace, I can do edit for Bacon Gobbler in the SAM namespace, and then we'll do a Helm kube context Bacon Gobbler install stable WordPress generate name, and we will deploy it into a different namespace. We'll deploy it into the SAM namespace. I should have actually deleted this role first just to show that it would not go the first time. But you'll see here that Bacon Gobbler now has write access into the SAM namespace and can deploy those in there and can actually see them too. So Helm kube context Bacon Gobbler list namespace SAM, and can't see them from the all namespaces typing. Can't see it at all from the all namespaces because that cluster role is not available, so you can only see that from there. And similarly, SAM can see it because SAM has read access to their own namespace. So we'll do SAM list. Don't need to give the namespace there. And you can see that it was deployed into the SAM namespace. So that's all I have for a demo here. That's all I have for time here. So left as homework for the reader, for anyone who is interested in this. There is, on Helm 3, there's the v3.helm.sh/docs. The goal of this talk was actually to add this as documentation so then everyone can benefit from this talk and everyone can benefit from role-based access control in Helm 3. So I'm going to take this as homework for myself as updating the documentation on this. The resources where I learned all about role-based access control in Kubernetes was on the Kubernetes documentation. And then I forgot to not leave a link on here, but there was a fantastic blog post by the Bitnami folks on how you actually create the roles, or not the roles, the users, and how that relates to doing all that with the TLS certificates and doing that with Minikube. So that's all I have for the talk. We actually have a decent amount of time, so I'll do a little bit of a Q&A if we want to. Otherwise, yeah, we'll go on to the next one. So thank you. Yeah.
Do you anticipate some of this turning into like a Helm init for Helm 3?
So the question was, do I envision this as being something like a Helm init for Helm 3? I'm imagining as in you're talking about how... It's a little bit of a tough question because all of this is very opinionated on what is exactly you're trying to deploy. Like you could have an opinion on whether you want to have a cluster role for viewing, editing, or anything else, completely dependent on what you are doing. So I think it might be better served as like a plugin to be assistive and saying like, here are some user profiles where you're really interested in, say, I want to give edit access to a particular namespace or things like that. I could see an assistive tool. I'm not entirely certain it would be such a great thing in there, because it would just be a massive splay of like feature flags to figure out your particular scenario for setting that up. So, but yeah, I definitely would see some kind of helpful. This would be useful for that. Yeah, Ivan. What? So the question was, why do we use secrets? Because it's so inconvenient. The good question, or I guess the question here was, or the answer here was, we were envisioning secrets now is going through some alpha stuff with encrypting at rest, and that's something that's been going through the Kubernetes API, and that would be something that would be awesome to see on the back end, such that like Helm releases could be encrypted at rest. So if you did a Helm install, the Kubernetes API would just encrypt it on the etcd backend, and then if you were to have your Helm client similar to like kubectl, be able to decrypt those secrets as it's being fetched. That would be a really fantastic security story. So it's kind of like we're waiting for things on the secrets backend to move forward. You can change the secrets backend to something else, but I guess we'll just see from here what's going on with the secrets backend. Yeah, that's actually a very good question. I'm curious to see on the Kubernetes side or point of view why secrets are not viewable by default using the default like roles in there too. Because they're secret. Secret. Yeah, I don't know. It's a very good question. Left his homework for the reader. Damn it. Yeah. Hi. Yeah. Yeah, so the question, it's a good question. The question was, if you have a chart that has templates that install resources in a separate namespace than what you currently have access to, will that like gain access outside of those roles? The answer is no, because when you're authenticating against the Kubernetes cluster and those resources are being installed, they're being installed on that Kubernetes user's roles. And that's basically, so when I did the first demonstration, I showed that you were trying to Helm install stable WordPress into a namespace which that user did not have access to. And if you were deploying resources that had a namespace hard-coded in there and that user did not have read or write access to that namespace, then those resources, it would just bork out and say that I don't have access to install resource foo in namespace bar, basically, is what would happen. Nope. Oh, hi. Hey, Paul. Mm-hmm.
When you did try and install it and it failed out, does it verify all of the resources you requested first before it tries to install them? Or will you end up in a state where half of the resources are installed before it got to that particular thing that you don't have permission to? Or you end up in like a weird, not quite installed state?
Yeah, so that's a good question. So the question was, prior to installing the resources in the cluster, does Helm actually verify that those resources can be installed and such that you don't get in like a halfway house where some of the templates are installed and some are not? It's my understanding, well, I'd actually have to take a look and leave that as homework to the reader, I guess. But the question would be, I'm fairly certain it doesn't. I'm not actually 100% too familiar with the code, but I think it does a schema validation with your user to see whether those resources can be deployed before it's actually deployed. Do you know by any chance?
Exception is if you have permission to deploy globally scoped objects, but not local objects, you could deploy a CRD and have that succeed, just the CRD, and everything else would fail. But that's the only exception I know of to the where you can do that.
Okay.
And that's because CRDs get deployed before the validation runs for the rest.
Oh, right. Yes.
Otherwise, the CR instance would fail. So.
Yeah, so it's a case of resources.
To configure your cluster to allow that, you've probably done something wrong. So the answer is it should fail. It should fail.
I think we have time for one last question. Yeah?
Yes, I'd like to relate but you want to limit them from getting to certain namespaces. Do you maybe know if that's possible?
Yeah. So the question is, if you want to grant roles such that the user can create namespaces but not create resources in other namespaces, and I don't think there's that kind of fine-grained control inside of Kubernetes where you can actually. I could be totally wrong. They're the custom, or so the ones that I used in this demonstration are the ones that are off the shelf, which give actions and verbs to certain names and namespaces or resources. And so like that secret reader role that I created, it was secrets get watch and list. I imagine there might be a cluster role binding where you could do for namespaces, you can create them, but that would be the only thing you could do, and you could apply that to a user and such that they could only use that in the Kubernetes API. So that could be a potential way of doing it. Yeah. So actually now in Helm 3, it doesn't create that namespace by default. So you actually have to create that namespace ahead of time before you deploy that Helm chart. So it's assumed that you have to have cluster admin access when you're first creating that namespace, and then the users have the fine-grained control or not on whether to install name or resources in that namespace. If you want to deploy a chart that has a namespace in there, then you need to give them role access to create a namespace as well as those roles. But that would be part of the validation that we were talking about. The only case would be with custom resource definitions that they could be installed prior to validation. Otherwise, all the other resources would go through validation and say, you don't have write access to create those names or those resources. And so you wouldn't get into that scenario where the namespace is created, but all the resources are not, because you have that role. It's my understanding that, yeah, that would be the case. Yeah. All right, I think we are at time here, so thank you, everyone. If you want to talk to me, I'll be outside.